Hi, I'm Paul Mason, and I'm going to speak today a bit about the deaths of stars, and specifically low mass stars. Now, low mass stars, which we define as being less than about 8 solar masses at birth, that's 8 times the mass of the sun at birth. High mass stars are formed with more than 8 solar masses. And the distinguishing factor is that at the end of their so-called lives, the low mass stars release a planetary nebula into space, releasing about half of its gas into space, and it leaves behind a hot white dwarf. And so I'm going to talk about those now. High mass stars produce supernova, and there's an explosion, and it leaves behind a neutron star or a black hole. So the low mass star deaths. So we look at the HR diagram, we can see that we have the stars form over a period of a few million years, go through the pre-main sequence stage after the protostar stage, and they join the main sequence. And this is the location of the sun currently. And after about 12 billion years, the sun will move off the main sequence and join the red giant branch, moving up here, becoming red and large. And then there's a helium flash, and the helium flash is the beginning of the fusion of helium into carbon in the center of the star. And when that happens, the fusion in the core of helium is taking place, and the star becomes yellow again, smaller, and it's on a horizontal branch, much brighter, but the same color as the sun. But then the helium runs out in the core, and it begins fusing helium into carbon in a shell surrounding the core, and that's what we call the AGB, or the asymptotic giant branch. And this continues, and there's lots of mass loss, lots of material lost by the star, and then the star releases ultimately all this gas, about half of its material into space, and that material can shine as a planetary nebula. The core is what's left over, and it's very hot and small, and being hot and small, it ends up very far over here in the bottom left corner of the HR diagram. So we can look at a little bit about the stages here. The sun's age now, it's about 4.5 billion years. It's going to 12.2 billion years after formation, it's going to be a red giant. And only 12.3, it will be on the horizontal branch. 12.33, the planetary nebula will be released, and then the core of the sun will be a white dwarf. And this is true for any solar mass star. Stars that have more mass than the sun will take less time, and stars that have less mass than the sun will take a longer time to go through these stages. If we think about a different mass star, we can look at the HR diagram for a 5 solar mass star, and it does a very similar thing. It has a red giant branch and a horizontal branch and an asymptotic giant branch, or AGB, and produces a planetary nebula. It's only when we get up to more than 8 times the mass of the sun do things change. So for the lower mass star, what happens is we have the production of these beautiful clouds of gas around the star, and these last only about 10,000 years. And so the star has lost its outer layers, the core of the star remains, and it's very, very hot, hundreds of millions of degrees. And because it's so hot, it's emitting ultraviolet light, and that light is shining on the gas that is escaping the star. And for that time period when the star is hot and the gas is not so far away from the star to be lit by the gas, and then the planetary nebula shines. So this is kind of like a neon sign. The ultraviolet light breaks the atoms apart, the electrons separate from the nuclei of the atoms, hydrogen, oxygen, and such that is in the gas, and the recombination as they combine back together, the electrons and protons and the oxygen nuclei with electrons, they produce these colors. And so after some time, about 10,000 years, the nebula, the expansion will continue, the gas moves further away. At the same time, the star is cooling down, and then the gas is still there, but it fades from view. And that gas is part of the recycling into the interstellar medium, where new gas in the interstellar medium, gas and dust, these elements that were fused inside the star during those previous stages are now available for new stars to be formed out of. So we can think of the idea that was presented originally by Carl Sagan, and that is that we are like star dust, and that is the elements in our bodies were fused together in the centers of stars. All of the elements heavier than hydrogen and helium, which is pretty much what most of our body is made out of, of things other than hydrogen and helium, all the calcium and iron and silicon and various things in our body are fused in stars. And so the low mass stars produce carbon and oxygen, which is a major component in our bodies. And so we indeed are star stuff. The elements in our bodies were made by stars. And so we see that these planetary nebulae are in all sorts of interesting different kinds of shapes. Here is perhaps the most famous, the Ring Nebula, and we can see with the Hubble Space Telescope the different colors indicate the different elements and the different amount of radiation that is ionizing those elements, breaking the electrons off the elements, and the electrons recombine to produce these spectacular colors. And so we think of this as not only the future of any low mass star, but it's also the future of the sun. And so the sun, it will eventually release this gas out into space about 5 billion years from now and produce one of these planetary nebulas. So that is the low mass star evolution.